My dear students, how are you today? I hope you are fine, and I believe you have been following our lessons. Don't forget that you have a task coming ahead. I want to believe you have been doing more than what is expected. You have been going beyond even the lessons. In particular, I hope you have done your assignments that came with each of our lessons. Remember, last week we decided to revise on this very topic that you have seen on the screen. Today is going to be the last series of the revision on this topic, carbon and its compounds. Last week we looked at the impure form of carbon, that is amorphous carbon. We started by the destructive distillation of coal. We look at that and we look at the products obtained from destructive distillation of coal. We also look at their uses of the products. We came to realize that out of the 4 products obtained from the destructive distillation of coal, that 2 of them are liquid, which include ammoniacal liquor and coal tar, while coal gas is a gas and coke is solid. We also went far to study charcoals, where we refreshed the knowledge of activated charcoal. We said when wood charcoal is being treated with steam and its ability to absorb gases increase and it becomes activated charcoal. And we have mentioned the uses of each of these: the sugar, the wood, the animal, and the sugar, including and also the soot, lamp black, and the carbon black, and their various uses. So today we are going to look at another section of the lesson called fuel. But before we look at that, let's look at the objectives of today's lesson. By the end of the lesson today, you should be able to define fuel, outline 3 gaseous fuels obtained from coal and their uses, explain what is biogas briefly, describe the production of biogas from biogas generator. This one is last year question or 2018 question. Right, let's look at this step 1 of the lesson. Fuels. There has been confusion even among the learned. When we ask of fuel, some people are fond of saying, I'm going to the filling station. The correct name is fuel station. It's not filling station. It is even not petrol station. because it is not only petrol is being sold in that place. So it is called fuels station, where you have the kerosene, petrol, diesel, and engine oil. All of these are called what? Fuel. So what is a fuel? A fuel is any substance that burns in air or oxygen to produce heat and lights. It's awesome. That is fuel. If you burn a piece of paper to boil water, the piece of paper is fuel, provided it burns in air to produce heat and light. Firewood is fuel, called biomass. Firewood is fuel. Anything that is capable of burning in oxygen to produce heat and light is fuel. Most fuels are carbon and its compounds. Hence, they burn to produce carbon dioxide and sometimes water vapor with the liberation of large quantity of heat and light. Let's look at types or classes of fuels. Classes of fuels. Let's look at number one, solid fuels, liquid fuels, gaseous fuels, human fuels, and atomic fuels. These are 5 basic classes of fuels. Solid fuels include wood, coal, and coke. Liquid fuels include your petrol, kerosene, alcohol, methylated spirits, and many. Gaseous fuels include producer gas, water gas, natural gas, paraffin gas, and synthetic gas. These three are more of industrial gases. We are going to look at them and their uses one after the other in the context of this lesson. We have human fuel, food items, fat and oils, starch, and sugar are what fuel. They're born. When sugar is burned in the human body, what happens? It produces what? Heat. Heat is produced. Right? Energy is being produced. The last one is atomic fuel. We are looking at atomic fuel for most what? Bomb blast. Uranium is an example of atomic fuel. Let's proceed to look at gaseous fuel that are being obtained from coal. Gaseous fuels from coal. We are going to look at about 3-4 gaseous fuels obtained from coal. Coal is embodiment of carbon, an impure form of carbon. The gaseous fuels that are extensively used for industrial and domestic purposes include water gas, producer gas, coal gas, and syngas are the synthetic gas. We are going to look at number one and its uses. Let's look at producer gas. Producer gas commonly is a mixture of carbon dioxide, CO plus. You can write it in full. This is SS3, is a mature class. So CO, you have to know it is what? Carbon dioxide and nitrogen. The major component of producer gas is what? It's a mixture of what? Carbon dioxide and what? Nitrogen. Take notes. It is produced by passing atmospheric air through red hot coke at about 1000 degrees Celsius. The process is exothermic. Take notes. Here we have the equation here. 2 moles of carbon react with 1 mole of oxygen with 4 moles of hydrogen to give us 2 moles of carbon dioxide and 2 moles of nitrogen. So you can see that this is called the producer gas. All right. The producer gas composed of 30% carbon dioxide and 70% nitrogen. You have to know, I taught you in FS2, nitrogen is compounds and nitrogen is what is an innate gas. It's non-combustible, right? Good. And it reduces what the rate of combustion of gases in the atmosphere. So if an industrial gas or fuel contains this greater amount of nitrogen, you know that the fuel is not that very, it's not very active. Take note, the presence of incombustible nitrogen reduces the heating value of the producer gas. I've said earlier. Let's look at the uses. It is used as industrial fuel to produce coal gas, iron, steel, and glass. 2. It is used in the Fischer-Tropsch process. Fischer-Tropsch process is a process of producing diesel oil from coke. It's called Fischer-Tropsch process. Let's look at next one. Water gas. This will be like a review. We have done this under hydrogen and its compounds and other topics. So I will not take much time because it's just a reminder and revision to you that water gas is an industrial fuel obtained from coke. It is a gaseous industrial fuel obtained from coke. It is the mixture of carbon 2 and hydrogen in 1:1 ratio, just like the ratio of producer gas, which is a 1:1 ratio of carbon 2 and nitrogen. But in the producer gas, it contains 1:1 ratio of carbon dioxide and hydrogen gas. The fuel is produced by passing steam through white hot coke at the temperature as we mentioned earlier. You can see on the screen. At the temperature 100 degrees Celsius to 1000, that is 1000 degrees Celsius to 1200 degrees Celsius. That's the range. So you can see the equation here. 1 mole of carbon reacts with 1 mole of hydrogen to produce 1 mole of carbon dioxide, 1 mole of carbon dioxide and 1 mole of hydrogen molecule. The process is endothermic. There is heat is not produced in the process. So, water gas consists or comprises 50% of carbon 2 and 50% of hydrogen, respectively. Water gas, you can see, hydrogen is a combustible substance and carbon dioxide is a combustible gas. So the heating value of water gas is more than that of producer gas because both carbon 2 and hydrogen are combustible, unlike nitrogen in the producer gas, right? Both are produced. Are we there? Both are produced both are produced after the order in the same furnace by passing steam and are alternatively through coke. Let's look at the uses. 1. Water gas is used in the production of hydrogen. You can see from the equation. We have done this under Blogas process, industrial method of producing hydrogen, Blogas process from water gas. When the carbon 2 oxide, when more steam is added, the carbon 2 will become carbon 4, and the carbon 4 can be separated from the hydrogen where we have the hydrogen. Number 2, it is used as a more useful industrial fuel. Since the heating value is greater than that of a producer gas, it has more industrial uses. We take number 3, synthetic gas. Synthetic gas contains the same components as in water gas, but the difference is that the ratio of carbon 2 oxide and hydrogen in water gas differs from synthetic gas. So synthetic gas contain carbon 2 oxide and hydrogen in the ratio 1:3. So the percentage of hydrogen in the water gas is more than that of carbon 2 oxide. Please, you can look at the equation as partially scattered. Please take notes here. This what you've seen here, let me have a barrel to point out at something, please. Yes, here, this is nickel at 900 degrees Celsius is used. So the arrow just scattered, the arrow is CO gas plus 3H subscript. So we have this. Alright, this is synthetic gas and the name is there. Alright, synthetic gas. Synthetic gas is a mixture of carbon 2 oxide and hydrogen gas in the ratio 1:3 respectively. Let's look at the uses of synthetic gas. 1, it is used as an industrial fuel of internal combustion engines. Used as industrial fuel of internal combustion engine. 2, as intermediates in creating synthetic natural gas, SNG. 3, it is used for producing ammonia or methanol in diesel. That is a Fischer-Tropsch process. And 4, for electricity generation. Syngas is used in generating electricity in the industry. Let's look at the next section of our lesson. All right, let's look at coal gas. Coal gas. Coal gas is the mixture of 50% of hydrogen, 30% methane, 10% carbon 2 oxide, 5% ethane, and 5% impurities such as hydrogen sulfide, sulfur 4 oxide, carbon 4 oxide, and nitrogen. These are the components. Take note, you'll be asked to state or outline the component of the following industrial gases or industrial fuel. Coal gas, 50% hydrogen, 30% methane, 10% carbon 2 oxide, 5% ethane, and 5% impurities such as H2SS, SO2, CO2, and nitrogen. Right, it has more heating value than producer gas since 90% of its constituents are combustible. Right, so it contains numerous gases that are all combustible. So it has more heating value than producer gas. Let's look at the uses. Coal gas is used as industrial and domestic fuel It is used in lighting, for heating, used for cooking. Right. Let us look. Now when we talk of use for cooking, you know that the gas we used for cooking, stored in a cylinder, contains part of the coal gas like methane and ethane. That's why we mention heating, cooking, lighting. All right, as domestic fuels. Let's look at the next section. We look at methods of separation of mixture of producer and water gas. In this aspect, we are going to look at if peradventure the water gas and the producer gas are mixed together, how do we separate the mixture? There are two methods of separating the mixture of producer gas and the water gas. One of the method is use of nickel metal. Producer gas passes over heated nickel. When producer gas passes over heated nickel, carbon 2 oxide is removed due to the formation of nickel carbonyl, leaving nitrogen or hydrogen. From the equation you have seen on the screen, the nickel reacts with 4 moles of carbon 2 oxide to produce nickel carbonyl. Here, the carbon 2 oxide can be recovered from the nickel carbonyl by decomposing the nickel carbonyl at 180 degrees Celsius. The equation is given below. Let's look at the uses. Number 2 is what? Use of ammoniacal solution. Use of ammoniacal solution in copper 1 chloride. The second method of separating the mixture of water gas from producer gas is the use of ammoniacal solution in copper 1 chloride. Ammoniacal solution of copper 1 chloride absorbs carbon 2 oxide and leaving nitrogen or hydrogen. So, these are the two methods we can employ in the separation of mixtures of producer gas and the water gas. In the next section of our lesson, we are going to look at biogas, which was written in our previous examination, but there is need to review as need arises. This is just a revision because 80% of this have been learned. Biogas is a fuel obtained from anaerobic decomposition of organic matter into the mixture of methane and carbon 4 oxide. Biogas is obtained from waste substances, waste agricultural and biological substances. Or we can define biogas as a mixture of gases produced by the breaking down of organic matter in the absence of oxygen. Meaning also, even almost the same thing, anaerobic decomposition means in the absence of oxygen. Biogas can be produced from raw materials such as agricultural waste, manure, municipal waste, plant sewage, green waste, or food waste. The gas, even in the toilet, the pit toilets. That's why it is dangerous for many people in the local villages still using pit toilet called latrine. It is very, very injurious because once the anus is being exposed to the pits, this gas is being liberated and it has caused a lot of harm, and it causes internal heat in many people due to this exposure, because when the waste substances being fermented, being decayed, the gas is being liberated. And for those that had experience of such in the local areas, you notice that the pressure that comes out from latrine is very hot. It is a gas, it is a biogas. Such energy can even empower turbines. So it is not advisable to use that. Remember, biogas is a renewable energy source. It is renewable energy source. A special device used for the production of biogas is known as digester, or you call it a reactor or generator. Okay, so in the next section of our lesson, we're going to look at the production of biogas from biogas generator. On the screen, you can see that biogas generator is a device that is used to generate the gas or the fuel called biogas. The organic waste or the biomass, when you talk about the organic waste or the biomass, could be the residue, the tissues of plant and animal, the municipal waste, the dumps, manure, all the waste. If you go to that very roadside where a lot of waste materials are being posed to, the place is very toxic. Even that incinerator that government keeps at the various strategic places, the gas being produced, if it is extracted, it is enough to generate electricity for the benefit of individual society. But because in Nigeria, there is no advancement, there is no knowledge, even when the knowledge is here, there is no facility to work on this. And the gases are waste in those places and rather generate harm to the citizens. So, the organic waste or biomass are fed into the digester, that is the generator, where different kinds of bacterial or microbial actions through fermentation process convert the decaying matter into biogas. So when the microbial organisms or bacteria decompose, acts on the waste to decay it. So the byproducts of the decay or fermentation is the gas that is being generated. The gas is not just an ordinary gas. It is a fuel that can be used for industrial purposes, even in electricity generation. And you need to understand that the biogas contains the following fuels. There are all combustible fuels, including methane, CH4, carbon 4 oxide, hydrogen, carbon 2 oxide, through the process of what? Anaerobic decomposition. Let's look at the uses of biogas. This could be the end of our lessons today. 1. Biogas is used for cooking. If you take a look at the coal gas that we have considered previously, and most of the gases we bought from the gas station in the cylinder contains these basic gases. It is a fuel used for cooking. One biogas is also used as industrial fuel in light and heavy duty vehicles. Light and heavy duty vehicles when compressed. 3. It is used in gas engine to convert the energy in the gas into electricity and heat. It is used as what? As energy to convert what? Certain energies to what? Electricity. 4. Biogas is used as the biogas is used as residue for fertilizer. It is used as residue for fertilizer. And finally, biogas is used for lighting and fuel. Lighting and fuel. This is how far we can go in our lessons today. The next section will be the assignments to keep you busy within the week. Look at the assignments there pasted on the screen. You are asked to state the color and one use of each of the following. 1 is silica gel. 2 is silicon for carbide. And 3 is explain what is biomass briefly. Explain biomass briefly. 3, give one reason why water gas and producer gas are usually prepared together in the same furnace. I want to believe the class has been exciting, having been revised of what we learned some times ago. As we are preparing to tackle the upcoming WAEC and NECO, that is need to continue doing this. I also want you to revise other aspects of chemistry in case time will not permit us to do it all. Thank you so much for listening. This is where we can stop in our class today. We shall continue from here on the same platform in our next class. Goodbye for now.